Yeah. Okay. I accidentally stopped the
Wait,
recording.
should we explain it now or should we do it after?
I think after this challenge problem.
Okay, so we'll do it after we're done with the challenge problem. I can explain that.
Yeah. Okay, so the question is convert 1912 base 10 to base 4. So use the baseline model to figure it out. We haven't really covered base 4 in class yet, so this might be harder, you know, but yeah. So again, it'll probably be harder. So in the chat, just type your answer. You should be able to solve it using the baseline model, which I will draw.
It's just the same thing as what we do for base 10 and base 2. It's just that instead of using numbers like 1, 2, and 4, you're just going to use 1, 4, 16, 64, and what's after that? 256? Yeah, 256, and so on.
Wait, how would you do it though? Because then there's 1, 2, 3, and 4 instead of just 1 and zeros.
It would be 0,
So
1,
you
2, and 3.
you can use 0, 1, 2, and 3.
It wouldn't include 4s, just like, yeah.
But how would you know which one to use?
So basically, I think so. So wait. So basically, say I had like 13 base 4, or like I wanted to express 13 base 10 in base 4, right? So what I'd do is I'd see, so 4 to the power of 0. So the greatest power of 4 that fits into this, that fits into 13, is 4 to the power of 1, right? Which is just 4. So how many 4s, what's the maximum number of 4s that fit into 13?
2.
It would actually be 3, because 4 times 3 4 times 3 is 12. So then we'd put a 3 here, right? And then 13 minus 12 would be equal to 1. So how many 1s fit into 1? The answer would just be 1. So we would have 31 base 4 is 13 base 10.
The reason why this is trickier is because instead of just subtracting the powers, you have to also multiply the powers to get like the largest possible one, if that makes sense.
Like you have to figure out how many of those powers fit
like
into
how many of that specific power fits in.
Okay.
Yeah. So like, you know how in base 10, yeah, as Aryan says, it works in base 10 as well. Because when you do like numbers like, 56, it's 5 times 10 plus 6 times 1. Yeah, so that is actually a math counts problem, and they will ask questions like that. That is a very common and good. It's a good problem too, and you have to use a little bit of algebra to do that. You would write that out as like 10a plus b equals 4b plus a, and then you would solve for b and a and find like the minimum value.
You wouldn't actually, you wouldn't actually solve for B and A. You'd solve for A in terms of B or B in terms of A.
Yeah. No, I mean, you could solve for B and A. Because it'll usually say what's the least possible value or something like that. You can do like 10a plus b and then 4b plus a, and then that would be 3b equals 9a. So then that means a could be 1 and b could be 3. And then you could just like plug it in. And that'd be the only possible value, because if you go more than that, then it won't satisfy BA in base 4.
Right, because there would be no number that could actually be it.
Yeah.
Okay, so I've gotten one answer.
I've gotten like 1, 2, 3, 4, 5.
Okay, a second person just answered.
I've gotten like 2 correct answers.
Right.
One person's very close. I think they had a typo.
Yeah, I think both people are correct. Yeah.
I got like 5. 2 are right, but I think one had a typo because they have like literally 1 digit wrong by like 1. So
yeah. I'm almost done with mine.
Okay, so I see someone who expressed it with only 1s and 0s. because it's in base 4, like it could hypothetically be expressed in ones and zeros. However, it is not. So like if you're getting an answer that's only ones and zeros, make sure you aren't like confusing binary with base 4. Okay, I've gotten 3 correct answers.
Okay, I've gotten 1, 2. Wait 1 second.
Okay,
Wait 1 second.
and just another thing, like even though like potentially all your numbers could be the same, this number like not like there aren't only 2 types of digits used. Like the person who typed the number as like in ones and zeros just did it again but with 2s instead of 1s, and that's not how it's going to be. That's not how you express this in base 4. So yeah.
I think we should explain it now.
Yeah. Okay, so I shall clear my. So when you're generalizing a base n number, you have n to the power 5, n to the power 4, n to the power 3, n to the power 2, n to the power 1, n to the power 0. And note that like the leftmost number can always go above n to the power 5. So you have the ones place here. So basically, when we're doing that for the fourth, for base 4, we have 4 to the power 5, 4 to the power 4, 4 to the power of 3, power of 2, and power of 1, and power of 0. So we find the greatest number of 4 to the power 5s that fits into the 1912, right? So what we do is we see that there's one possibility. There's one value of 4 to the power 5 that can fit into 1912, right? So that means that we have 1912 minus 1024. And when we do that, we get 800, we get 788, right? And then we find how many 4 to the power 4s fit into that, and that's 3. And then we find how many 4 to the power 3s fit into that after we have subtracted 3 256s, and we get 1. And then we do the same for the rest of the numbers until we get 3 to n to 0. So we know that our base 4 looks like this, and it only uses.
Wait, but how would you work with those other digits? So like I know when you're doing base 2, 0 would mean that. Wait, so how would you work with the 3 and the 3 and the 2? How would
For
It would be 3 times
right, so
4 squared and 3 times 4 to the 4th.
Right. So when we're doing that, we subtract 1024 from 1912, we get okay.
Wasn't there an easier way you sort of a formula in the during the school year we had?
In the what?
During the class, like the Mathema classes in the school year.
Oh, the previous course, like a formula?
Yeah.
To find the number in base 4, like
yeah,
converting to any base.
No, it's the formula itself, like the easier technique was only to convert it from base 10 or like to base 10, and sorry, it was only to convert it from base 10. So basically we saw that many people like after that did not like they did not understand that you couldn't use that for other bases, and they were using it for other bases, so we decided not to like teach that. So yeah.
Sometimes it like instead of helping, it just adds more confusion because they don't understand the fundamental of why.
Right. Like,
and so they do something that you would do just for base 2. They would do it for all the bases and it wouldn't work.
Right. So that's why we didn't teach it. It was easier, however, it confused many people. So yeah, that's why we didn't do it. But yeah. Okay, I have a question. Does anyone have any questions? Like any other questions about this?
This just takes time. I mean, you can't expect to get it the answer in like 5 seconds.
Right.
Unless you're like really good.
Right. Okay. So if no one has any questions, we can move on.
Oh, we already did that. Okay. So hexadecimal. So hexadecimal is just base 16. So hexa means 6. So hexadecimal, so 6, 10. But the problem is, so in bases like 6 and 7, and any base below 10 or including 10, we can only go until the like n-1. So for base 10 we can only go until 9. For base 2 we can only go until 1. But when we do numbers like base 16, we can go until 15, right? But the problem is it's kind of hard to express 15 in 1-digit place. So for every number after 9, in math we write it as a letter. So 10 is A, 11 is B, 12 is C, 13 is D, and so on. But this is only applicable for numbers that are base 11 and after.
Right.
Because
And
that's when you'll use it.
yeah. And also just a thing to remember, A is 10, not 11. I see a lot of people make mistakes and they think it's 11, and then that messes up their math, even though they knew how
Any
to
number
do it.
that's 2 digits has to be expressed as a letter.
Right.
And 10 is not 1 digit. So
right. So remember, A is 10 and not 11. Just keep that in mind. So
this is a simple concept, but a lot of people overcomplicate it and don't understand it. So does anybody have any questions?
Wait, so how would you express like 37?
okay.
In base 16?
Well, like if you were to go more like after base 16.
Okay. So specifically for 37. So so the greatest power.
Wait. I think she's saying if we do 37 in bases that are less than 37.
Oh no, how would we just write 37 in generally? Because you said every 2-digit number has to be a letter, right?
Yeah. Okay. So to clarify that, what it's meant is every 2-digit number that needs to fit into one place value.
Oh, you know what she's saying? So when we start with 10, we have like 26 letters in the alphabet, right? So
Right,
10 plus
right.
26, we only go until 36. So if we have 37 and we need to fit it into 1 digit, what are we gonna do?
That was probably my fault. I probably should have said that.
Okay. Well, here's the thing. I don't know, but the thing is, they're never gonna ask a question, and that's all you need to know. They're never gonna ask a question, and I guarantee you,
no one uses like great bases like
and I guarantee you, the highest base that you're gonna see is base 16, because that's the highest base that has real world applications in things like programming and computer science and stuff like that. So you're never gonna be put in a situation where you have to deal with a base, I would say, greater than 16. And if it is greater than 16, it's not going to be like 37.
It's not where you're going to have to like rethink a whole math concept, right? It's going to be something where you can use the things you know already. So
yeah.
How would you change the programming like default to something other than base 10 or the decimal system?
Oh, in like computer science?
Yeah, in coding.
It's not even coded in base 10. It's coded in base 2. It's not coded in base 10. The computer doesn't know what base 10 is. Everything that the computer knows is what we tell it.
Oh, when I write variable a is equal to 12, then how does it know what 12 is?
Well, that's like
it doesn't actually understand what 12 means.
It doesn't know what 12 means.
12 is just a concept to it. 12
so
is
everything
just like,
that we have taught it what 12 is. So we make 12 think it's binary.
It's like, okay, it's not actually doing anything. Like it's not truly understanding. Like for example, if I tell you everything blue goes into this box, right? That's what it does, but like at a more complex level, right?
Yeah.
So it's just doing like compartmentalized.
Just think it's like, you know, it's a calculator. It doesn't understand why it's doing what it's doing. It's just doing it.
So, so then how does it do 12 minus 10? Because it has to have some understanding of the number.
No, it doesn't need understanding. It's kind of hard to explain just because computer science can be so complex.
It's complex because of how simple it is. Because
so you know, programmers have found, I mean, they're geniuses. They found, you know, very advanced techniques of how to make super complex things.
Basically what the computer does is, so you use a programming language, right? So there's some programming language like Python used, and that programming language basically has this thing where it tells you, okay, this function or this whatever means that you do this, right? And to do it, it takes very basic things like it doesn't even use like, you know, real functions basically, because each of those real functions is broken down into just bits, right? So then that's like it just it does everything.
It doesn't understand anything, so it's not like
it's like mindless.
Yeah, it's hard to explain. It just has numbers, and it has like greater numbers and less numbers, and you know, it
doesn't interpret any of it.
It doesn't interpret. Yeah, it doesn't interpret anything. It just does it.
But if you wrote like
the programming language would tell it, right, but the programming language would tell it, would tell the computer, like not tell the computer, but it would say, run this function, right? Like it wouldn't say, like it would not know what, like it does not understand the 12 and the 10.
The computer doesn't solve for 12 minus 2. The 12 minus 2, like 10, sorry, 12 minus 10, the programming language would write it out differently, which then the computer would be able to like read the whatever it is, would be able to read the program language and do it in a different it would do it in a different function. So yeah, binary is more used in data representation just because it's less complex, and you can write any number in terms of ones and zeros.
Okay, so you
we need to cover the content, so we can
this
talk
is kind
about
of unrelated.
Right, sorry. Okay, so I do have a question about like the bases. If you write a letter for 2-digit numbers less than 16, then when you go to rewrite the number, do you leave the letters in the number? So I'm assuming that you mean, like, for example, if I wanted to convert A1, right? So like that would be like 161 of that, right? So that would be, so A1 would just be 161 if it were in base 16, right? So basically what that would mean is that you would not keep the letters. You would convert it to the base. You know, you would not keep the letters that you have used. The letters are just numbers expressed in a different way. The letters aren't like permanent placeholders for anything. So I hope that answers your question. So yeah. Okay, does anyone have any question? Okay, if not, so try to convert this number to base 10. So 2AD8. So remember that the places, the place values, like, so you have to multiply the place value by the number. So try to do this. So you will have 3 minutes. So 11:11.
Wait, so when it says like one place, did you mean like 16 to the power 0 for the?
Yeah, that's what it means. Because any number to 0 is just 1.
Okay, yeah.
Yeah, and eventually you won't even need this.
I mean, if you do need it, it doesn't like mean you're like bad at math or something, but like it'll just become
you won't though. Like if you do more, you won't. I've gotten my first answer. gotten 2 answers. I don't know if they're right. I haven't solved it.
Yeah.
Okay, yeah. Okay, so one of them is right.
Okay. So remember, when you convert a number to base 10, all you're doing is multiplying the place value with the value in the place value. So yeah. And remember, if the leftmost values have zeros in them, you do not have to care about them. Like 0 plus 0 is always going to be 0, you know. The number for all intents and purposes starts right here. So you do not really have to care about this. Okay, so there are 3 answers. 2 of them are correct.
I've gotten 1, 2, 3, 4.
Okay.
Yeah.
How
And
many
3
of
of them were correct.
Okay, that's good.
Yeah.
So again, we didn't really talk about base 16, but the same principles used for other bases apply here too. So yeah. So make sure you're multiplying, like, you know. Okay, I got 2 other answers in the public chat, I guess, would be the name. Okay, so, okay, another answer. So a lot of people are getting this correct, which is great, right? So basically, what you're supposed to do is you're supposed to multiply the place value by the number in it. So 16 cubed times 2. The value of that, so 16 cubed would be equal to, so 16 cubed times 2 is 8,192. So we get 8,192. Then 16 squared times a is 10. So 16 squared is 256, times 10 is 2560. And then d over here is 13, so 13 times 6 is equal to 208. And then we just do 8 times 1 and we get 8, right? So we add these together and then our final answer is 10968. So yeah. So I think everyone who I've seen so far has gotten it correct. So yeah, that's good. But again, if you got it incorrect, in the chat, please type like what questions you have or you might have. And yeah. And if you don't have any questions, again, type that in the chat, please. Okay, I don't see anything in the chat. Okay. So one person has no questions. Does anyone else have any questions?
Wait, 1 second. Sorry, I have a lot of people saying stuff in private messaging, so I have to reply to all of them. Nothing really.
Okay.
Nothing to worry about.
Okay. So here's the explanation, basically, and we get that answer. So uses for hexadecimal. So one common use, as we talked about during the break, is coding colors. So colors have 6 digits each. The first 2 represent red, the middle 2 represent green, and the last 2 represent blue. So that's called RGB. And this is
we're doing computer science now?
Well, I mean, it's applications.
Yeah, I know.
Yeah. Okay, so this is written in RRGGBB, but you substitute the digits for.
By the way, you guys don't need to like know this super well for AMC. This is just a side application in real life if you're curious.
Yeah, so 2 hexadecimal digits can represent 0 to 255. So that's how many shades of each color there can be. So you can have 256 cubed possible colors, like combinations. So yeah. So you can also write colors in RGB decimal format, which is RGB and then the numbers, right? So 255, 255, 255 in RGB can also be expressed as pound FFFFFF, which is white. So over here is just like a diagram with the colors. And okay, so basically, how did we change 255, 255, 255 to FF, FF, FF? So basically, each of the decimals corresponds with 2 letters in the hexadecimal code. So why, okay, so why does 255 equal FF? And that's just because F in the 16's place would be equal to 15, 15 times 16, right? And F in the 1's place would be 15 times 1. 15 times 16 plus 15 times 1 is equal to 255 because it's 240 plus 15. So that's why FF is 255 because it's just hexadecimal. So that represents the, so white has the maximum amount of red, green, and blue. Okay, so, okay, so, can you repeat that?
Nothing. I was just saying it makes sense now why there's, whenever you look at colors, there's letters in it.
Yeah, yeah. Okay, so for practice, so try to find this color in decimal. So how would you write it using RGB? So in the chat, you can private message me or Ashab, or you can put it in the public chat. How would you write this in RGB?
If you have any questions, I suggest you ask Ashangi. I'm really bad at computer stuff. I'm just saying. I'll answer the math questions, but this stuff, I'm very bad with computer science.
Yeah. Okay, so I'm not seeing any answers yet. It's okay if you're still working, you know, but make sure you're going to type the chat to us, like in the chat, your answer to one of us, so that we know you're participating. Okay, so I've gotten one answer.
So we're using 16 as our base, right?
Yeah. And
okay.
Remember 6, 8 base 16 and 9, 0 base 16 would not be equal to 68 and 90 base 10. Because I've seen that use that.
I'm confused because whenever I calculate EC, it gives me a number more than 255.
So E is 14 times 6. Okay, E is 14 times 16, right? And that would just be equal to 224, right? So 224 would be what the E represents.
No. I remember now. I thought I calculated C times 16 instead of just adding C.
Oh yeah, that would explain. So, okay, I see one answer, or another answer. Okay, so I have so far only seen one correct answer. So like make sure you're not assuming that 68 base 16 is equal to 68, or 68 base 16 is not equal to 68, and 90 base 16 is not equal to 90. Okay, so we will wait for 2 more minutes, and if no one else responds, then we will just continue explaining, finish explaining this problem. Okay, remember that 6890 EC is not one number, but three numbers. So yeah.
So EC is one number, 90 is one number, and 68 is one number?
Yeah. So they are not, so they are three numbers and not one. Okay, so I've seen many answers, so let's just explain this. So the answer is 104, 144, and 236. So how we get this? So 6, 8, base 16 would have a 6 in the 16th place and 8 in the 1's place. So we multiply 6 by 16 and we get 96, and multiply 8 by 1 and we get 8. So we add them together and we have 104. Now for the 90, we have 9 times 16, which is 144. And then there's a 0 in the 1's place. So we would just have a 0. We add 144 to 0 and we get 144. And then for the EC, we just multiply the 14, which is what E represents, by 16, and we get 224. And then we add the 12, or the C, and you get 236. Does anyone have any questions? If not, we can move ahead. Okay, so there are a couple more problems. However, since we're running short on time, we will talk about adding and subtracting binary numbers. Okay, so yeah. In the chat, Rashab, can you put the thing in the chat, the link in the chat for the Jamboard? Okay. So basically, adding numbers in different bases is just like adding numbers in base 10.
A lot of questions will be in like adding and subtracting. Wait, I'm sending the link in the chat. Sorry. Wait.
Okay, so adding numbers in different bases is like adding numbers in base 10. So we would have, so 2 in binary would be, so sorry. Okay, so we would have this. So this is, this is 1's place, 2's place, 4's place, right? So 4 plus 2 plus 1 is 7, right? And then you'd have 1 and 2's place, which is 3, and then you'd have this, and then you'd have the 8's place, right? So 3 plus 8 is 11, right? So 11 plus 7 is 18, right? You first have to convert them to base 10 before adding them, just to make it like less likely for you to make a mistake. So you have 18. What?
Wait, so is it impossible to add numbers in base or in any other base apart from base 10?
It's not impossible, however, because many of the addition rules that people have learned, or all of the addition rules you've learned, are in base 10, you might like accidentally like not carry over when you should, and it's just easier to not add correctly when you aren't in base 10. However, you can add in other bases, but like, you know, it's gonna be like hard. Okay.
Wait, so I'm just guessing here about how you'd add in base 10, but would it be you'd add 1 and 1, but the max amount you could have is 1, so you'd only put the 1 down, and then you carry the 1 over to the next number, and you keep doing that until you...
Yeah, that's how you do it. But first, but because we have learned converting numbers, you should do it like we have already learned converting numbers and bases, right? So you should just use converting numbers rather than, adding it in the base itself. It's just much easier to make a mistake when you're adding it in the base itself, at least from my experience. If you are better at adding it in the base, that's fine. Okay, so this is 18. So 11 plus 7 is 18, right? And then to convert 18 into base 2, so we know that 18, the greatest power of 2 that fits into 18 is 2 to the power of 4. Then 2 to the power of 4 is 16. So 18 minus 16 is 2. So 2 to the power of 3 would have 0. 2 to the power of 2 would have 0. 2 to the power of 1 would have 1. And then 2 to the power of 0 would have 1, right? So the answer would be 1, 0, 0, 1, 0, right? So you can do that. So that's one way you can do it. You convert it to base 10. Then for this, if you want to add it in the actual base, so what you do is you'd add 1 and 2 in base 1 and 1. So that would sum up to 2 if we were in base 10, right? But since 2 cannot be used, it carries over as a 1, right? Because there is 1 power of, there's 1 to the power of 1 that fits in there. So 1 plus 1 plus 1 is 3. So you would have 3 minus, so this would be 3, 2 to the power of 1s, and that would be equal to 6, right? But so we only carry 1 down, right? Because
wait, I don't understand. How would 1 and 1 equal like 0? Like even in like when you're adding it.
The greatest number that fits into this is that fits into base 2 is 1, right? So when you have 1 and 1, it's 2, right? But then 2 expressed in base 2 is 1, 0. So that's why you're carrying the 1 over.
Oh.
Yeah. So you'd have 1, 1, and 1, right? So basically, when you add these together, you have you bring down 1, right? But you have 2 remaining, and so basically this is 6, right? And 6 so 1 plus 1 plus 1 in the 2's place is 6, right? So we carry down 1, which would be 2, and then we have a 4. So we'd bring that over as a 1 because 2 to the power of 2 would be 1. And then so 1 plus 1 would be equal to 2. And then that 2 carries over as a 1. And then we have, so it would add up to 2. However, 2 expressed in base 2 would be 1, 0. So we have 1, 0, 0, 1, 0, which is what we got earlier. However, because we're running short on time, this it might be harder to understand. And because we haven't really explained in depth adding and subtracting the numbers, you might not understand this, like doing it in base. This in the actual base itself. However, you should be able to convert it to base 10 and then subtract or add them and then find the final number.
I have a question. So is it basically for binary, the 2 number, if you get a sum of 2, then basically it's counted as 0 when you're writing it down. But if you're carrying it over, then it's 1.
Yeah. So basically, yeah, so 2 expressed in base 2 is 1, 0. So you carry over the 1 and leave the 0. However, if it were like 3, right, if it added up to 3, you'd carry the 1 and leave a 1 in that place because 3 expressed in base 2 is 1, 1 base 2. So yeah.
Okay, that makes sense.
Okay.
So it's basically the same thing as converting, just with extra steps.
Right. Okay, so I shall clear the drawings. And then subtracting binary numbers is also similar. So 1, 0 and 1 base 2. So we would basically borrow this 1, right? And because it's base 2, we'd get a 2 up here, right? When we carried the 1 over. 2 minus 1 would be 1. So we get 2 minus 1 is 1. And so, for example, let's try a bigger number. So we could either convert these 2 numbers or we can just subtract like normally. So let's just convert them because we have more practice in that. So 2 to the power of 0 would be 1, right? 1 times 1 is 1. And then 2 to the power of 3 times, okay, sorry. So that would be 1 in the ones place, right? And then 2 to the power of 3 times 1 would be 8. So 8 times 1 is 8. So that first number would be 9. Then for the second number, it would be 2 to the power of 0 for the 0 and 2 to the power of 1 for the 1. So that means that it would be 2, right? So 9 minus 2 is equal to 9 minus 2 is equal to 7. So yeah, so that's how you would get 7 and then you would convert it to base 10 or base 2, sorry. So base 2, 7 would be equal to so 1 in the 2 to the 3 and the 2 to the 2's place, right? 1 in the 2 to the 1's place and 1 in the 2 to the 0's place. So yeah. So you guys are free to leave.